Welcome to the validation of your lab kit. So in this lab activity, you're going to be testing your own skills at creating a lab workspace, and you're going to be testing one of the tools that is in your lab kit. First, wash your hands thoroughly. Next, use some sort of cleaner to clean the area that you're going to use for your lab space. You're now going to test that your balance is working properly. So first you need to make sure that the batteries are actually in your balance if you haven't done that yet. The directions for this are in the cheese lab video, but make sure you put those batteries in before you check if this is working. This balance can measure a lot of different kinds of units for mass, and you can change between them using the mode button. You always want to measure in grams for this class. So you should see a little G up there. If you don't see it, press mode. Right? You can kind of cycle through and see all the different options, ounces, a bunch of things that I don't even know what they are. But you always want to use grams for this class. So if you are not in G or grams, you just want to cycle through, clicking the mode button until you get back to grams. Now you're going to validate your balance, which means you're going to check and see if it's measuring mass correctly by measuring the mass of things that have a standard mass, or where their mass should be already known. Alright, so the first step here is to open up the balance and get it turned on. Now the weighboat protects the surface of the balance, so you're going to put that on there and you're going to zero the balance, or tare the balance, and then you're going to try measuring a penny, which should also have a fairly standard mass. Go ahead and photograph the mass of the penny on the balance. Now you can Google what the standard mass of a penny is and see if your balance is giving you the right output for the mass of this penny. Pennies should all have about the same mass, right? So you can try this with another penny if you have one to hand and see if the masses are relatively close, as they should be, or if they're far apart, which is a bad sign that your balance is not working. Right, because the two pennies should really be about the same mass. And then you want to try this again with some sort of standard mass object that you have around your house. So another type of coin or whatever, something small that has a standard known mass. I measured the mass of a dime, which should be less than the mass of a penny. You can look up what that should be. You can measure other small items if you want, but make sure not to put anything too heavy on the balance, so nothing over 500 grams, which is about 9/4 worth. When you're done, don't forget to turn off the balance. Make sure you put the balance and the weighboat away. And anytime you finish any kind of lab, you should always make sure to wash your hands thoroughly. What is the 10% error method, you ask? Okay, let's say my object of standard mass was a dime. So that's the one that I picked. You do the same process for your penny and for everything else. So you want to Google what the standard mass is. So for a dime, right, the US Mint, which makes dimes, says that the exact mass should be 2.268 grams. Okay. What I found when I measured it was 2.32 grams. Okay. So there's a bit of a difference there, right? But we got to determine if that's a significant difference or not a significant difference. So to figure out if this is a big difference or a small difference, you're going to use the percent error formula, which basically is your experimental value minus the exact value or true value divided by the exact value, and then times 100. That's where you get your percent, right? So our experimental value, my experimental value here, was 2.32 grams. Then I subtract the true or exact value that I looked up on the internet, so that's 2.268 grams. And then I divide both of those, so once I've subtracted, I divide both of those by the true value, which would be the 2.268 grams. And then I'll multiply all that by 100%. Okay, when I do the subtraction here, I get 0.052 on the top there, divided by 2.268 grams times 100%. It's going to give you your percent error. All right, so when I divide these two values, I'm going to get over here, I'm going to get 0.0229, right? That's probably plenty of decimal places. You don't have to write the whole thing out, times 100%, right? So this times 100 is basically going to be 2.29% error. Go ahead and circle your answer always, right? Anytime you're doing any kind of math. So that's our percent error. So long as this value is within 10%, then you're fine, or less than 10%. It can be positive or negative, it doesn't really matter. As long as it's less than 10% as absolute value, then you're within 10% and your value is close enough to the true value that this experiment is valid. So in this case, I've got 2.29%. That's much less than 10%, which means my balance is accurate.